I'm going to take a guess and say you've never played a game with Dynamite, Tornado, Quicksand, Pit Chain, Gun, Law, Whip, Sword, Rock, Death Wall, Sun, Camera Fire, Chainsaw, School, Scissors, Poison Cage, Axe, and more. That's right, we're playing Super Rock, Paper, Scissors with 101 different moves. This is episode 19 of the Python project. Let's get it. Let's begin by importing the libraries for regex and random. I was able to get all of the moves and winning combinations from this website right here. As you can see, here are all of the ways you can win with each move. However, this website is not scrapable. We can't use the requests module to get the information off of the page. So what do? Well, we can copy and paste all of this into a text file that I've conveniently already done. So once you do this, you just need to read it into Python. I used split lines to get rid of the new line character that appears at the end of every line when you read in a text file. So if we open this up and look at the first 20 items, we can see this pesky tab right here. Smoke blows out sun and explodes camera should be two separate items, but instead they're one. So let's check out the rest of combo list and see if this issue persists. So I just ran this and let's see what it returns. Okay, so there's 5 lines in total that have this annoying tab. In order to split this up properly, we can do it like so. For each of the tabbed items, I'm going to find where it's located in combo list. Then I'll split it up by the tab so that we'll have a list of 2 elements. At the location of the tabbed item, I'm going to replace this double grouping with the first element after we split it. So if we look at the first item in tabbed items, this appears at index 12. So now, instead of index 12 being this whole line, I'm going to make index 12 equal to smoke blots out sun. Then I'm going to insert the second item of the tabbed group into the index right after this. That way we can ensure the second item is still within the same move. So the first item in tabbed items belongs to the move Dynamite. So we want to make sure that explodes camera stays within Dynamite's possible victories. We'll do this for each of the items in the tabbed list, and that will take care of that. Then we have a bit of cleanup to do. We're going to remove all of the blank lines from combo list because we don't need them. And we have some information at the bottom of the list that we don't need to include since it's not relevant to the strategy of the game. In case you're wondering, here are the 3 items that I removed in this line. As you can see, it's just information about the website, so we don't have to include it within combo list. Within combo list, we have to find where each move is located. That way, we can identify how to split the list up so that we get all of the ways each move can win. We use regex to create a pattern that will look for 1 or more numbers, followed by 0 or more spaces, then a hyphen, and finally a space. If you want more practice with regex, check out my video at the top. Filter is a really easy way to apply a function to a list and only return what is true. In this case, it will only return items that follow our regex pattern. So if we run this, you can see that we have a list of all of our different moves. So here are all of the moves, and we can check to make sure there are 101 moves. And there are. And here are the indices of each move within combo list. Once again, we can confirm, are there 101 indices? And there are. Between each index, though, are the ways you can win, so we need to get that information. Well, we can loop through move locks and make it a list of sets to do this. It can be structured like so. The first set will have the 0th and first element. The second set will have the first and second element, and so on and so forth, all the way down the list. However, when we do this, we will miss out on the last grouping, which is the last item in move locks, 5100, and then the rest of the combo list all the way till the end. So we can manually append that to move groups. Now that we have our grouping, we can easily create a dictionary where the keys are the moves we can make, and the values for those keys are lists of how the move can win. So we make an empty dictionary total moves, and then we loop through each of the groupings that we just made. In each grouping, if we apply this against combo list, the first element will always be the move, and the rest of the elements will be the way in which that move can win. So let's take a look at the first group. For dynamite, we can see that in this list, the first element is indeed dynamite, and the rest are the ways dynamite can win. So now that we can visualize this, you can see that the first element will be the key, and the remaining elements will be the values for that key, which are all the ways in which that key can win. This bit here, where we're splitting it by hyphen, taking the first element and then stripping it, that's done so that we can retrieve only the text, not any of these numbers or hyphens, for each of the moves. Eventually, we're going to have to write these moves out to the console, so not having to include the numbers and hyphens will make it much easier for us to write. Finally, we can write the code to play Super RPS 101. Let's start by creating the variable GameStatus, which will either keep us in the game or quit based on what we tell the game to do. Then we'll make a while loop that will only run if GameStatus does not equal quit, and then we'll ask the user to input their move. There's a very little chance I'm going to remember all 101 moves, so I'll include it at the bottom as a docstring so I can always reference it. We'll run our test to make sure that whatever we input is indeed one of these choices. If it isn't, this while loop will keep us in this loop until we pick one of the possible choices. I decided to add quit here because we're going to need it if we want to quit the game. Speaking of quitting, we can now write the logic for that. So if you choose anything other than quit in the list of all possible choices, the program will randomly pick a move and assign it to the variable computer move. Now, this code is super ugly, but bear with me, it's actually very simple. The first if statement checks to see if our move appears in any of the ways that the computer can win based on what it chose. We use a lambda function to do this, and all possible ways the computer can win is dictated by this, total moves bracket computer move. So if we chose rain and the computer chose vampire, it would look like this. So it would look in here to see if rain is in any one of these elements. In order to actually do that, we can use our lambda function to test this out like so. So there are two entries where rain appears, but one of them isn't what we want. Stocks in rain is fine because it has the whole word rain, but never sees rainbow isn't good because rainbow is a possible move you can make, and for the purpose of this game, it has nothing to do with rain. So to get around this, this is why I've included .split after x in each of these lambda statements, because .split will take stocks in rain and never sees rainbow, split it up by spaces, and then check each individual word to see if it matches rain, like so. In this case, rain is not equal to rainbow, so it won't return never sees rainbow. When we run it with x.split, it only returns stocks in rain. This else if statement does exactly the same thing, however it looks for the computer's move in all winning combinations of your move. This else statement will print out a tie to the console if neither condition could be satisfied, and the last else statement will change the game status to quit if our initial move that we typed out was indeed quit. Last but not least, let's put this into production. What's my move? Okay, let's say I type in tornado. Rats the computer won. Toilet survives tornado. Okay, maybe I can type in castle. I won. Castle has beer. This game is amazing. And one more. Let's do something big. Maybe butter. Fantastic. According to Super RPS 101, butter floats on quicksand. And if we want to quit, we just have to type quit. And it looks like we're good to go. As if rock, paper, scissors wasn't already complicated enough, you've now written a version that has 101 different moves. If you enjoyed this episode, make sure to hit that like button and subscribe for more episodes of the Python Project, and I'll see you in the next one.